The Earth is a planet of immense power, and few forces on its surface are as awe-inspiring, as destructive, and as scientifically complex as the tropical cyclone. We know them by many names: typhoon, tropical storm, and, most commonly, the hurricane. But whether it's ravaging the Gulf Coast of the US, making landfall in Southeast Asia, or churning across the Indian Ocean, these storms share a common, terrifying anatomy, an engine of pure atmospheric chaos that can unleash the energy of 10,000 nuclear bombs. They are one of nature's ultimate displays of raw, unbridled power, capable of reshaping coastlines and altering human lives in a single day. Before we can understand how they form, we need to know what they are. A hurricane is a type of tropical cyclone, a rapidly rotating storm system characterized by a low-pressure center, strong winds, and a spiraling arrangement of thunderstorms. The terms are interchangeable based on geography. In the Atlantic and Northeast Pacific, it's a hurricane. In the Northwest Pacific, it's a typhoon. In the Indian Ocean and South Pacific, it's simply a cyclone. But they are all one and the same: a massive, swirling vortex of wind and rain with the potential to reshape coastlines. The key thing that distinguishes a hurricane is its location and wind speed. They form over warm ocean waters, typically between 5 and 30 degrees latitude. This latitudinal range is crucial, as it provides the perfect balance of warm water and sufficient Coriolis effect for rotation. If the winds reach a sustained speed of 74 miles per hour, it's officially a hurricane. The intensity of these winds is what we measure. We classify them using the Saffir-Simpson Hurricane Wind Scale, which gives them a category from 1 to 5 based on their sustained wind speed. A Category 1 is a dangerous storm, with winds from 74 to 95 mph, capable of causing minor damage to homes and snapping power lines. You might see shingles torn from roofs and small trees uprooted. A Category 2, 96 to 110 mph, can tear off roofs and uproot trees, with winds powerful enough to cause extensive damage to older mobile homes. A Category 3, 111 129 mph, is considered a major hurricane, causing devastating damage and snapping large trees. It's at this level that widespread power outages and significant structural damage to well-built homes become common. But a Category 5? That's what we call a catastrophic force of nature. With winds exceeding 157 mph, a Category 5 hurricane can cause the complete destruction of residential buildings, leaving an area uninhabitable for weeks or months. Its winds can strip the bark off trees and launch vehicles into the air. The raw energy released by a storm of this magnitude is almost beyond human comprehension. Think of a hurricane as a giant heat engine, and the fuel is warm ocean water. For a storm to form, you need a precise combination of ingredients, a recipe for chaos that is surprisingly difficult to achieve. First, you need ocean water that's at least 80 degrees Fahrenheit, 26.5 Celsius, and at least 50 meters deep. The sun heats this water, causing it to evaporate rapidly. This warm, moist air then rises, and as it does, it cools and condenses into clouds, releasing vast amounts of energy in the form of latent heat. This is the key. When water vapor condenses back into liquid, it releases the heat it absorbed during evaporation. This released heat is the true powerhouse of the storm, causing the air to rise even more, creating a powerful low-pressure zone at the surface that draws in more warm, moist air from the surrounding area. This process is a continuous feedback loop, powering the storm's growth. The deeper the warm water, the more fuel the storm has, allowing it to intensify even in the absence of a surface-level heat source. Second, you need low wind shear. Wind shear is the change in wind speed or direction with height in the atmosphere. If the winds are too strong up high, they can rip apart a developing storm, blowing the top of the vortex away from its base and preventing it from organizing into a single, cohesive system. A calm upper atmosphere is key to allowing the towering column of thunderstorms to grow vertically and become a formidable, spinning machine. This is a primary reason why El Niño conditions often suppress hurricane formation in the Atlantic. The strong upper-level winds across the ocean create hostile conditions for storm development. Conversely, La Niña conditions often lead to less wind shear and more active hurricane seasons. Third, you need the Earth's rotation, known as the Coriolis effect. As the air rushes in to fill the low-pressure zone, the Coriolis effect causes it to deflect and begin to spin. In the northern hemisphere, it spins counterclockwise, and in the southern hemisphere, it spins clockwise. A simple way to think of this is like a spinning ice skater. As the skater pulls their arms in, they spin faster. The air rushing in towards the low-pressure center of a hurricane works in a similar way, consolidating its rotation and increasing its wind speed. This is also why hurricanes cannot form directly on the equator. There is no Coriolis effect at the equator to initiate the spin, which is essential for storm formation. Once all these ingredients come together, the storm begins to feed on the warm ocean water, growing larger and more powerful. It's a self-perpetuating cycle of heat, moisture, and rotation that can lead to some of the most intense weather events on the planet, all fueled by the heat of the sun. A hurricane is more than just a big storm. It has a distinct structure, a blueprint of its power, a perfect machine built from wind and water. At the very center is the eye. It's the most famous part of the storm, and for good reason. Surprisingly, the eye is often a calm, clear, and quiet area. The skies clear up, the winds die down, and the sun might even peek through. From within the eye, the surrounding eye wall can be seen in a spectacular stadium effect, looking like the walls of a giant coliseum. This is an eerie, deceptive calm, surrounded by chaos. The eye is calm because the air is sinking in the center of the storm, warming and drying as it descends. This descending air suppresses cloud formation, creating the calm center. This is also why people who are in the eye need to understand that the worst is yet to come, as the eye wall will pass over them a second time from the opposite direction. Surrounding the eye is the eye wall. This is the most dangerous part of the storm. It's a ring of towering thunderstorms where the fastest and most destructive winds are found. It's here that the heaviest rain falls and the strongest storm surges are generated. This is the region where the most intense upward motion of air occurs, drawing in the warm, moist air from the ocean's surface and sending it spiraling upwards in a violent vortex. In powerful hurricanes, the eye wall can undergo a fascinating process called an eye wall replacement cycle, where a new, larger eye wall forms around the old one, causing the storm to briefly weaken as the inner wall dissipates before re-intensifying. Finally, extending out from the eye wall are the spiral rain bands. These are long, swirling bands of thunderstorms that can stretch for hundreds of miles. They can produce heavy rain and strong gusts of wind, and often spawn tornadoes as they move over land. The rain bands themselves are a series of mini-storms, capable of causing localized flooding and wind damage far from the hurricane's core. But perhaps the most dangerous part of a hurricane is the least visible: the storm surge. This is an abnormal rise of water generated by a storm's winds pushing water on shore. It's not a giant wave like a tsunami, but a massive dome of water that can rush inland, inundating coastal communities and causing over 90% of all hurricane-related deaths. The surge can rise rapidly, trapping people and cutting off escape routes, making it the greatest threat to life. A 15-foot storm surge can travel miles inland, completely submerging single-story homes and buildings in a matter of minutes.